Hey guys, number 9, we have an electrolyte in an automobile lead storage batteries is 3.75 molar sulfuric acid. Has a density of 1.230 grams per milliliter. So that's our molarity. Our density. Calculate the mass percent and molality. All right, so we have 2 questions, 1 and 2. Sulfuric acid, right? Sulfuric came from sulfate. Sulfate, SO4, that's 2 minus, right? Hopefully remember sulfate is 2 minus. And so we got H2SO4. Okay. Now, one of the things I like to write out is this and this. All right. We have 1.230 grams of solution per 1 milliliter of solution. And this is 3.75 moles of H2SO4 per 1 liter of solution. All right, those are my ratios. Okay. Now, mass percent and molality are also ratios. So we have all ratios. There's no amounts. All right, we don't have an amount. And so I need an amount, right? Because we always need an amount. So we're going to assume 1 liter or 1,000 milliliters. Because if we assume a liter or 1,000 milliliters, this makes us, it's nice. Okay? So with 1,000 milliliters, right, we got 2 things here. And I'm going to cheat on you guys. Sorry about that. Oh, no, not that. We're going to move this over to this way and move this one over to the left. And so now we're going to rewrite these. All right? So I have my density. I have 1,230 grams per 1 liter. And then I have 3.75 moles of H2SO4 in 1 liter. So now I have some things I can go with now. So mass percent first. That's the mass percent of H2SO4. That's going to be grams of H2SO4 over grams of solution, which is the grams of H2SO4 and grams of water. Right? But now, because it's grams of solution, I already have grams of solution. Right? Because I have 1 liter. I have moles of sulfuric acid in those grams, right? So we can take our 3.75 moles of H2SO4, right? And we know that 1 mole of sulfuric acid, you got 1.01 for hydrogen, right? You always need your periodic table, okay? Or access to one. Sulfur, 3207, and 4 times 16. So if we do that, plus 32.07 plus 16 times 4, calculator, I get 9809. All right. So in my solution, or our solution, I guess it is, right? 3.75. I get 0.038. No, that's not right. I did this backwards. You're probably looking like, what's he doing? Let's go with the correct units. So I just made a mistake. So this is 1 mole H2SO4 and it's 98.09 grams. This is why you write it out. Does that make sense? And do the math, right? Because there's a lot of people. I was guilty of this when I was going through this. We're just doing the math, just taking numbers in the calculator and not writing it out. So when I write this out and I got the number, and that looked pretty low, right? My number was less than 1. Well, that doesn't make sense. If I have 3 moles, 3.25 moles of sulfuric acid, it should weigh more than 1 gram, all right? Because 1 mole weighs 98 grams. You know what I mean? So that's why you write it out. Look what you did. So I made that mistake, which now it's been corrected. So 3.75 times 98.09, 376.8. So 367, sorry, 367 grams of H2SO4. All right, so if I do that, 368, rounding. Because I got 367.8375. So 368 grams of sulfuric acid divided by our 1,230 grams of solution equals 368 divided by 1230 times 100 is 29.9. All right, so there's our mass percent. Now we got to do the molality, number 2. And the molality would be what? Moles of H2SO4, kilograms of H2O. All right. So I have moles of H2SO4, right? That moles of H2SO4 in our 1 liter. There it is. Right? There's our moles in 1 liter. So that is done. Now I need kilograms. Well, we know I have 1,230 grams of solution. We know that we have 368 grams of H3PO4. Now, because we're in chemistry land, we're going to assume that it's only sulfuric acid and water. There's nothing else in there perfectly. So 1230 minus 368, I get 862 grams of water. All right, which happens to be 0.862 kilograms of water. So now we can do this. So my molality, or our molality, would be what? Our moles of sulfuric acid, which is 3.75. And our kilograms, 0.862 kilograms of H2O. And our molality would be 4.35 is what I got. So that is how we do that one. All right.